starting with what we can, what happened to architecture and what happened to architect is what I would like to start with. And I would want to give a case study of a project that we are doing as a community development in remote villages of Madhya Pradesh, that is in the central part of India. So initially, if we start the journey of architects or the architecture from the Stone Age, it was mainly the architecture was for the gods, for the temples, for the fortresses, for the palaces. And then came the major transition in the world called the first industrial revolution in 18th century, where the energy was coal, the transportation was rail, and the communication was telegram. Then the role of architect shifted from a normal thing to a revolutionist, to an economy builder, to a perpetuator, to an industrial idealist, to an innovator. From a manual labor to a mechanized production, it started happening. And then came the second revolution in 19th century, in about 1900s, where the energy was shifted to oil, the transport was shifted to roads, and the communication was shifted to telephone. Now with this, the role of architect changed to a very different level, where he started thinking about a nation building. He became a builder, nation builder, country shaper, philosopher, thinkers, planners, because the production of materials was started to initiate for the mass, for the individual to mass. And that's, I think, we still, architects are continuing that thought process, that what we can be able to produce for the mass people. Then came the final and the recent revolution that is called the third industrial revolution, where the energy has now shifted to renewable and solar energies, because we all are aware of the quite evident incapacity, or I would say the fundamental vanishing of the other sources. The transportation is definitely the mass, and communication is internet. So in this digital world, the role of architect has again changed. Now he has become, rather than a mass producer, he has become to produce a customized designer. So he has to create an individual identity. He has to also act as a service manager, specialist designers, providers, project managers. From mass to customized production, there stands a very big challenge that the producer of the designs and the consumer of the designs versus the factor is changing a lot, the ratio is changing a lot. So what was expected actually out of an architect was that he should be able to create an interpersonal relationship of people. The communities or the spaces should be more peaceful, should be more inclusive of itself. But what we have landed is we are aware of. But in all this amid, we had a different world. So in the mid of all this, we have a different community that exists. Maybe not in our lectures, maybe not in our presentation, maybe not even in our books of architecture, but there lives a whole community which is unaware of what an architecture is, what is the development is. To them, there's a different world that exists. That world is something an architecture really needs to cater to, because what is an architecture? Is actually a sense of embodiment of space that responds to social, cultural setting, keeping in check in all the economic parameters. So here I would want to present that every generation is responsible for safeguarding the world of future generation. And I think right now we are suffering this. Somebody can call it global crisis. In Sri Lanka, we can call it a political economic crisis, but somehow the draft towards changing of technology, usage of a lot of parameters are now leading us into a very handicapped situations. There were possibilities of cement plant, there were possibilities of imports of a lot of things which have somehow stopped, and we are left at a node, or I would say at a corner of economy where we are not able to move forward. We feel more paralyzed. We are understanding that the architecture is there, but the materials that we understand as architects are not there. This parallelism is actually deterring us inside to create a possible solution. So in this whole conference, I want to portray an example that maybe in the books we understand architecture with few guidelines, with materials, with building technologies. But let's look at the third world where these do not exist, and how examples and how situations have been overcome. If that can happen, we definitely have a solution. It's just the mind that we have to change. So if I talk about what is sustainable, we have a lot of conferences, we have a lot of Dubai Expo, we had about sustainability. To me, the sustainability is the ability to continue over a time. Be there be a social, economic, political, disaster, any type of parameter. We can continue, that is the sustainable. What is sustainability? Is that with the current needs, we have the possibility to complete it without affecting the future generation needs. And what is architecture? It's the art or science of building. So what is a sustainable architecture? And I would want to term in my way, it's like building our own future. If we can, and if we are able to, I don't think anything can hit us. And an architect is supposed to be looked at as a person who can give the solution. And that's how we are into this conference, to find a solution. So I want you to guys, everybody, get up with a journey where I was trying to find a solution to a problem. And I will not end with the answer. I just want you to enjoy the journey. So I talk about a very primitive village in remote areas of Madhya Pradesh, that is the central part of India. It's a Patan. The dream of making a village like it should be education, healthcare, smart village, it should have disaster relief, better care, better world. What we would want to add more is quality education, there can be revenue, reviving of art, women empowerment, organic and skill development, organic farming and skill development. So coming to the center part of India, I talk about a very special city called Khajuraho. I'm sure most of the architects would have heard about it. It's a temple city. It's a UNESCO heritage site, and it lies on the border of two states. In India, we have, like in Sri Lanka, we have provinces. In India, we have states. So two states, Uttar Pradesh and Madhya Pradesh. At the border of these two states, there lies a very beautiful city, Khajuraho. So from Khajuraho, we have a very nice Panna Tiger Reserve. So it's the most prevalent tiger reserve in whole India. It is sighting about 50 to 60 tigers per every time. So it's mostly visited by all the wildlife and photographers and anybody who is into this exploration of nature. So this whole Panna Tiger Reserve is actually surrounded by hills of Vindhyas. Vindhyas is the central hills of India. Along that, the blue line shows a very dynamic river. It starts from jungle and is very fast, very heavy flow, and it ends also in jungle. So this river has a possibility to increase or decrease with a lot of gush of water. And this is the yellow line is showing the spine of the road network. Majorly, the government aids are provided to the villages which are next to the roads or near to the roads. So I'm talking about a village almost at the yellow location. This is very far, about 20 minutes from the main road. And this particular village has suffered a lot of problems during floods, during economic crisis, during different part of the India's freedom movement. So what happens is the Tiger Reserve used to already have a lot of villages, about 40-50 villages. In 1970, there was a proposition in which all the forest department decided to boundary the Tiger Reserves. Once they are bounding the Tiger Reserve, the villages were supposed to move out. Now these villages were only gatherers and hunters. They didn't know the urban life, they didn't know anything. But once moving out of the whole jungle, now they have to survive. So they were new to agriculture. What was agriculture common to us was very new to them. So I'm just talking about 50 to 70 years of lifespan and 50 to 70 years of total mind, culture, economic shift in this area. So this whole area is actually having about 50 to 60 villages. But I'm talking about one village which is very small, which we could actually work out if the solution works for this village, we can replicate in most of the areas. So coming next, so this is Khajuraho, a very beautiful place, a very, I would say, flooded by a lot of foreigner tourists, but yet the government aids are in very different, discrete manners. So this is Panna Tiger. This is Panna Tiger Reserve, very beautiful valleys, rivers, waterfall, tigers, amazing, amazing life. So here I'm telling about how the site is located in a very prime way, but very affected in the sense of development. This also has many dams, but all these dams are giving water to the nearby states. They are not giving water to this area. So all the villages are suffering a lot of waterfall during the rainfalls, like a situation of flooding, but during the dry summers they are actually crying for water. So most of the villagers are crying for water. So this is the blue box. Purva is the village. So what happened during this time? These people were still dependent on forest. They had the houses made out of timber with terracotta tiles on it, and they were living with the mud houses. They were trying to manage their way. The floors were more of cow dung floors, rammed dirt plinths. So what happened is Madhya Pradesh government and most part of India banned the forest cutting in the area. So now these people were suffering a lot of situations in which houses could not be repaired. When houses cannot be repaired, whatever you give them education, they are not ready for that. You give them women empowerment, they are not ready for that. You give them best of the organic facilities of growing agriculture, they are not ready because the houses are in a very dilapidated condition. So let me show you how the villages look like. So it's a village of about 30-40 houses. Currently, almost all having hut-shaped dilapidated structures made out of timber. Few have resorted to government funding and got these brick cement houses made, but those houses are too hot for the temperature, and either they would need electricity or they cannot stay in the house. So it's a very debatable situation right now. Major agriculture is their source of income. So overall, they have the two spines of the villages. Of the whole village is running about the two spines with a lot of houses which are closely, densely knit. Before initiating what can be done, what should be done, we started to understand how this village is, how it survives, what is their culture, how they live. So this was the existing condition. They had either the rammed earth walls or they had the brick with only the mud mortars and a very bad network of water drainage. I think it's getting too dark over here. So this is how a traditional house looks like. And the problem is not with the house. The problem is with the repair of the house. The roofs are breaking. The timber is not available because they cannot cut it from the forest and they cannot afford to buy it from the, I would say, the vendors of wood. And the terracotta tiles these days are not made anymore because they are very labor intensive. So now the solution was very challenging to us. You know, we as an architect would understand if a client comes with a beautiful brief of making a farmhouse or making an urban house, we can give a solution, and yes, we are good at it. But somebody who does not understand where is the problem and is able to survive very minusculely on his resources, we are not able to give a solution. So as an architect, I was helpless in understanding what should be done. Yes, there are many case studies all over the globe, but on this location, in the budget, in the timeline, how can we do it? So understanding their lifestyle, the way they live, the cook, the type of spaces they need for storages or interactions, we tried to understand what were their major activities. So they had to walk for defecation for the toilets because the toilets in the house had a problem for the sewerage water management. Even the smell that was in the house was too prevalent, so most of the villagers have stopped using the toilets. They were built by the Indian government under Swachh Bharat Abhiyan, but they were not used. Similarly, with the cooking, they were given the cylinder and they were given the burning hob, but they could not afford to refill the cylinder, so they have stopped using the cylinder and they like to eat the food cooked on the twigs or the trees part. So they have to go walk for the cutting of smaller parts of trees unofficially into the jungle. And they have to take the kettle, they have to do the washing, bathing, things. So house, I would just take one aspect. As an organization, we're doing the whole aspect of sustainable approach, but house was something we architects can relate to, and is also a journey of finding what a solution can be. So we started to visiting a lot of places which had done research over post 50, 60 years of independence of India. So we went to National Institute of Rural Development to understand different type of constructions they have done for different regions, like for Kutch, like in Bhuj we had a very big earthquake, in Northeast we had a different climatic condition. So different type of prototypes were made and how they can work. So we went, we understood the sanitation power, biofuel, we understood these guna tiles. So a lot of things. Then we went to Aruval Earth Institute. We understood how brick is actually having the right strength, which in architecture schools we know by Louis Khan, you know, the brick wants to become an arch. But how many of us, I ask you, use actually a brick arch? Really, none of us are able to change the arch, and we are now starting to use the concrete reinforced metal lintel beams. So now if we don't have iron in a country, we are stuck. If we don't have cement in a country, we are stuck because we have forgotten the various ways of architecture. So how a brick can actually take strength and load and can convert into different wall structures, can act as a roofing, which is very tough. See, we can understand a roof can be made, but you understand from a villager's point of view, they have to make roof themselves. They have to renovate. They have to even expand where the family expands. When they have 3 sons, when they grow, they are married, they have to expand. So expansion also has to be taken care of, which is very tough. So then we started to understand about the mud houses. I understand mud house. You believe mud house is good for them. But what do they believe? That was the question, what do they want? They don't want mud house. They are already living in this. They don't want it. So here comes the factor of aspiration. You are talking about sustainability, ecological cycles. They talk about their aspirations. Their aspiration comes from an urban world, the type of architecture we are doing. Their aspirations are built that we want a brick house. We want a house to have a flat roof. We want to, have a nice positioning in the society. We want our daughters to be married into a right house. For that, we need that house. We do not accept your brick house, a mud house. It was a clear statement. We do not want a rammed earth mud house. And we are talking about sustainability over here. But they don't want it. It's simple. So we went an understanding of what are done all over the parts of India about mud houses. We even went to what Laurie Baker had done with the stone foundation, with the rat trap bond, how he has incorporated the Kerala people and created a very naturally ventilated systems. Yes, we did read everything in the book, but to understand what people think about it, you have to go there, understand from them. Then we started to understand if the modern way of pillar system, if we can adopt that in the brick structures with just giving a little RCC lintel beam and doing some walls. Can we do it? We found studies we can do it. Then we understand, yes, there exists a water and daub system. Many of us know, but nobody used in the urban architecture. That the bamboo reinforced with either the mud plaster or lime plaster or straw reinforced can be used with mud flooring. Then there exist straw-based wall structures. This is good for thermal mass. It really makes the temperature cool down, but it has its own problem of organic growth. There are fungus, there are muds, there are a lot of things. So people don't want it. You want to give, but they don't want it. It's a simple climate stuff. So then we went to these very beautiful mud structures where you have the glass bottles, giving it very nice shape, also keeping it cool and having the light inside. Then eventually we started to understand the major problem of the houses lies in the roof. And we started to explore this tumbler style clay tiles which could be manufactured in the nearby area. So if you have village, you could convince 2-3 potters to manufacture the clay tile tumblers, and these tumblers can be assembled in a wall structure with a very little of cement roofing and broken tiles to reflect the sunlight, and it can actually reduce the temperature to about 10 to 15 degrees inside. So if the temperature outside is 52, they can have a nice temperature of about 35, 32, which is too much when there is no electricity, there is no cooler, there is no AC. So this is the type of the look that happened. So we understand the built material is, it should be durable, eco-friendly, the technique should be replicable, low maintenance, structure should be allowing future expansion, should be climatic responsive, should use ergonomics and spaces, and should actually have their lifestyles. You cannot ask, what happened. Many of us know the example of Le Corbusier's Indian Habitat building, where it was made for people who were from the lower caste of the society, but then it was made in floor structures. So then it was not habitable, that was never able to use. They used to rent out and move to different spaces. So we have to maintain the way of open, closed and combined spaces they had. So there were many options for doing filler, column, mortar, backfilling, grills. I'm not going into details, but we had many options. And we understood about how the foundations can be done, door, flooring, plastering, stairs can be done, walls can be done. Then we came to a very interesting material, which I knew existed, but we never had this opportunity or challenge to use it because there was never a context, there was never a situation. I would, as an architect, say my building needs this much of brick, my building maximum can have cement concrete blocks, hollow ash blocks, and that's all. But when the situation happened, I came to understand there is a material proficiently used called compressed stabilized earth blocks, which is totally just earth. So there's just earth inside, just 6% of cement to give it a little strength, compressed with a machine, sun-dried, ready to use, and it can take up strength to 3 floors. So tell me, as an architect, how many of us are making 3-floor buildings and we are using the best of best technologies that are to be used for the dams? Reusing the concrete walls, shear walls, just for 3-floor buildings. Most of the projects I saw here were just not more than 3 floors. And we are using the most profound materials. And we have the simple material called CSEB. It can take, it is low embodied energy, durable, made on machine. So machine is also very simple. It's just a compressed machine. So you just need to compress. So people can be trained with it. So once we understood this in Araval, we said, let's try it. But the challenge was, then we thought we'll just make 2 houses, but the bricks was a challenge. Where to get it? Nobody is making, nobody is manufacturing. So as an organization, we thought, let's take up the land, let's put up a small machine of brick, an automatic machine that can produce bricks. So then we also understood the ergonomics of how the spaces work. We understood with the scheme of how we can develop the houses. And this is how we started developing the roof structure, the balconies, the tiles, the ventilation systems, the washrooms, the soak pits, the boundary walls. So after making these 2 prototypes, we realized that we need to take a space and make a real prototype because the villagers will not be convinced. They don't want your earth structures. It's a simple fact, they don't want it. So let's make something for them. So we took up a community site, we made this site, and then we developed a shelter like this to produce brick, and we made a little office to make sure we can be on site and start taking care of it. So this structure was made, and the machine was brought from Araval. This is a simple machine, requires very limited electricity. It does require a nice, I would say, clay soil and just water, that's it. And these were done by the local people. So there were 2 traders who came, gave us the understanding of it, then the local people used to do. And it can produce about 2,000 bricks per day if it is run to 16 hours, and maximum it can produce 4,000 bricks per day. So we also understood that the brick is sorted, but the roof is still pending. So we talked about this Guna tumbler tiles, the type of, we talked about this jack arch roof where you are placing the small side bricks on a beams so that you can have a wall structure, or you could talk about this filler slabs where the concrete is used in a very less manner. But this is an RCC slab with a very less concrete, and in between you can have lightweight tiles, pot forms, or you can have a herde slab. I don't know if it is the same name in Sri Lanka, but these are more like a hollow tiles. So they are put on the precast beams, and that can be used. So this is the final look of the house, and let me just take you through it. So we have provided only the lintel beam with a concrete reinforced bamboo, not concrete reinforced steel. And the plinth is also, and the lintel beams are also. We could not reduce the amount of cement, but we could reduce the amount of, we could not make it zero, but we could reduce it to very less level. And steel was 0. So even the walls are CSCB and with the line, and with the mortar is mud mortar, mud lime mortar, and the windows are all bamboo windows, and the flooring is also, some part is having stone, some part is having IPS, some part is having lime. The boundary wall is made of rat trap bond with some part about 2.5 feet of bamboo. So these are the toilets. The toilets are kind of a sock pit toilets. They are 2 holes. I'll explain in the further slide. Rainwater harvesting system, rainwater management system. So we have also given little shelves for their utilities with little stone like a kota stool. In India, the cheapest is the kota stool. So this is the rear yard, how it looks like. This is the intimate areas of the house. This is how the staircase is building into house, where we have done a brick wall and then did a staircase on the house. Some storage areas because they cannot have cupboards. Interrelationship between an open, closed, and a semi-open spaces. Some places to keep their pots. So all the walls could be exposed with the CSCB or could be done with the lime mortar or mud mortar as per the choice. So we have given this rocket chula. So you can see here the roof structure we've done. This is a prototype house. So we have done the guna tile also, we have done the herde also, we have done a filler slab also. So this is a toilet which I never knew existed. A toilet having 2 soak pits, and with the type of rapid aerobic degradation. So if this waste, human excreta, is kept inside it for about 6 months, it will just vanish with air. So you just have to need to give a pipe so that the foil air can get out, but that's it, it will just vanish. So 6 months, one pit is active, the second 6 months, the next pit is active, and that's it. So you just need to put 1 liter of water that they also take to their desification when they go into the, village lands, and you just put a sawdust so that there is no smell in it. So that's it, simple. So you don't need any sewerage management system, and we architects are somehow STPs, we are just handicapped with it. So this type of system worked very well. So we had this chula because they were not ready to go away with the traditional chula. Plus the source of fuel was very simple. The wood that we take from the forest and can be used without any cost. So this rocket chula is, you will only have to use 1/4 of the fuel required. So we could not do 0, but we can always do very, very least quantity. So with one burner, the hot air from the one burner is going to the second, and that second is also used for making chapatis or just heating something. And then there is a chimney, a little chimney that takes the exhausted type, or I would say carbon air outside, so they don't have to cough when they are cooking. And we had done this very simple technique of covering the wells with a hand pump. So wells were already made, but covering the head. helped in, there was no dust, there was less evaporation of water, and there was, in villages if you go, there are some issues like dead bird, or some bird is flying, it throws a dead animal into the well, so you just can't use it. Then the villagers cannot use it. So covering this totally eradicated any problems. So here I end with one thing, that yes, there are options. As an architecture on the core level, when we dig deep, we have so many ancient techniques which are working well. It's just that we have not formulated them into I would say, a very textbook language. They are evaporating in between us and making us handicapped. Personally, if you ask me, like Badri said, this situation is a more potential situation. We are actually sitting on golden eggs of creating architecture in a way world has never seen. I'm sure many people are from Bangladesh. They would have understand how the parliament building became a relic in a situation where they needed it. How I'm from Chandigarh, Lanka Museum made it a city which was not possible in whole India. So whenever the situation is different, here comes an opportunity for the whole architecture fraternity to change the way. So we are moving more with it, something that I'm moving out of my domain. I'm still moving because these are also affecting my architecture, like the Miyawaki forestation we are doing over there. We are trying to do the waste management over there, reducing the plastic to a very high level. We are trying to create a community center where people can be trained to a lot of small scale opportunities. We're trying to incorporate solar, which is very easy, permissible, manageable.